Today we're doing section 2.5, and it's scatter plots and line that best fits, also known as prediction equation. There's already a video explaining the first question of the worksheet. We're going to go through the other questions right now. But before we even begin, we're going to be getting some information, some data, and we're going to be plotting it on an XY plane. And sometimes when you plot your information on an XY plane, you have positive correlation, which really means positive slope, right? Negative correlation, right? It's like a negative slope going down from left to right, or no correlation, right? So something that has positive correlation would be like, let's say, age and height, right? So like a 2-year-old will be a certain amount of height, right? And then a 4-year-old's taller, a 5, 6. As you get older in age, you get taller, at least till you reach your late teens, right? But anyway, that's an example of positive correlation. If we did start taking random information, age and height, you would see that there's a positive correlation. Now let's say we take some information of something that's totally random, like let's say foot size and I don't know, ice cream choice, right? That makes no correlation, right? If you get that information down, it's gonna be all over the place, right? So let's first begin by saying, okay, positive correlation, the points are pretty close together and it looks like it's going in a positive direction, positive slope. Negative correlation, there is some type of relationship, the points are pretty close together and it's going to negative. No correlation because it's all over the place, they're not really related. Anyway, this is the worksheet that we're doing today. There's already a video explaining number 1. It's asking us to do several things and nothing is new. Everything is based on what we already know from last week. So it should be an easy section. So let's jump to number 2. And what we want to do is plot these points, okay? So when we take a look at the first input output, the first coordinate, 5, 9, we have to really make sure that we understand the units that this graph is going by. On the x's, it's going 5, 10, 15. On the y's, it's 8, 16, 24. So it's actually going by 8. We got to first be careful and understand that before we start plotting any points. So when we look at 5, 9, let me really get down and explain to you where 5, 9 would be at. You see, we are going by 8, right? From 8 to 16. 5's easy, but from 8 to 16, to get an accurate idea, you'd have to chop it up into 8 pieces. So if you took 8 and chopped it in half, you would be at the 4 mark, right? If you chopped that in half, you'd be at the 2 mark. And if you chopped that in half, you'd be at the 1 mark. So I hope that makes sense, that this is 8, this is 9, 10, 11, 12, 13, 14. We need a 15 right there. And then obviously 16 would be up here. So 9 would be ridiculously close to the 8. Ridiculously close to the 8. So that was the first coordinate. Second coordinate will be 10, 17. 10 on the x. 17 on the y. It's going to be slightly more than 16, ridiculously close. But don't go up halfway. Remember, it's going by 8, so 17 will be ridiculously close to the 16. And what I would like you to do is plot the rest of these points. So I'm going to pause right now. I'm going to let you guys plot these points, and then I'll continue the video with everything plotted. Go for it. So I hope everybody's had enough time to plot your points. This is what you should have. So what we should do now, well, first of all, do we have positive correlation, negative correlation, or no correlation? Positive correlation, that's right. You could clearly see that it's going upward from left to right. And let's actually get a line. Now, I don't want you to draw this yet, but maybe you could use like the edge of a paper or a pencil. But if I draw a line, okay, and this line needs to be the line that best fits. So what I'm going to do is I'm going to pick 2 points and see which line would be the best one that represents this data. So if I put it right here at this first dot and the second dot, okay, that would be using the first coordinate 5, 9 and the second coordinate 10, 17. That obviously is not a good line that fits this data, right? So we're not going to use the first dot and the second dot. So like you probably wouldn't use the second one and the third one either. That doesn't look that good, right? You might not use the middle two. So if you're playing with the line, of course, with you on your paper, you're probably using your pencil or the edge of a piece of paper. And if you go through the points, it looks like, in this case, the first one and the last one are pretty good points to select. And that's exactly why I highlighted, right? I put a highlighted dot right there and a highlighted dot right there, because those points are really nice. It really does give us a line that best fits. It's not always going to be your first point and your last point, all right? It just depends. As you test each of the points, see which line fits best. That's why it's called the line that best fits. Okay. So that is the line that best fits. However, we want it algebraically. Okay? We already said it has positive correlation. Maybe I should write that down. Positive correlation. This blue line is the line that best fits. And we did conclude that the first point and the last point were really good to use because it gave us the line that best fits these dots, the scatter plot. All right, so we're going to actually, so since we're using the first coordinate, the 5 and the 9, and we're using the last coordinate, the 40 and the 44, we need to produce the equation of this blue line. And this is what we just did last week. Right? What would we do with 2 points? We would find the slope. So I want to zoom in and do my work here. Here's my slope formula. And of course, we need to label these coordinates, x1, y1, x2, y2. And when you plug it in to your slope formula, I recommend using blank spots as you plug in. The y2 is 44, the y1 is 9, the x2 is 40, the x1 is 5. And maybe I shouldn't have done this one because it's ridiculously easy. When we get to 44, take away 9, we get 35. And on the bottom, 40, take away 5 is also 35. So we get 1. The m equals 1. Now, let me tell you right now, this is highly unlikely to happen, especially when you have real data, real things. The slope's not going to be a nice, beautiful 1 or a nice, beautiful 2. You're going to get nasty fractions in the real world. You're going to get decimals, and that's totally fine, especially because we could use calculators, right? So there will be times where your slope is 0.75, and that's okay. When you write your equation, you could use a decimal. You could put 0.75 where the m belongs. But as of right now, last week, we learned that when you have points, we have 2 points, and you have a slope, what could we do? Point slope form, right? So let's do that. Y minus y1 equals m parenthesis x minus x1. And whenever I use any formula or form, I like to rewrite it with blank spots. That's the safest thing to do. That's what I recommend. And it looks like we're going to use this first coordinate, x1, y1. The numbers are nicer than the second one. So the y value is 9, the m value is 1, the x1 value is 5. Now, this is the equation that represents the line that best fits, but we want to write it in slope-intercept form. Again, this is exactly what we did all last week. So let's distribute the 1, which is not going to change anything. So you're going to have y minus 9 equals x minus 5. Final step would be to add 9, giving you your final line that best fit equation being y equals x plus 4. This is it. That is the line of best fit right there. Also known as prediction equation. Right there, okay? This guy, I mean, in the real world, businesses use prediction equations all the time. They get data, they plot it on a scatter plot, they get this prediction equation, and they will be able to predict when they start making a profit or when they start taking losses, et cetera, et cetera. And let's use this prediction equation to answer the final question or the final step right here, part C. Use your prediction equation to predict the missing value. So here's our XY plane. and the last input-output value is 50 and question mark. So look, if I go to 50, where's my blue line at? It's going to be up here somewhere, but of course I want it to be exact, so I'm going to use my prediction equation, which we just said was y equals x plus 4. So if I did have y equals x plus 4 and take that 50 and plug it in to the x, because the x's are the inputs, you'd have y equals 50 plus 4, which equals 54. So that's what belongs right in here. So the input 50 gives you the output 54. And once again, I want to mention this. This ended up being a nice equation. This rarely happens. It's usually decimals, fractions. Use decimals. It's okay. Let me show you what I'm talking about. Instead of looking at number 3 and actually doing that, I want you guys to do that one on your own. But I'm going to take a look at the answers over here provided to us. So they used the second coordinate and the second to last. So it's not always going to be the first coordinate and the last coordinate that they give you. Just depends which one would work best. And you know what? Let's just let's challenge that for a bit. Let's see. If I draw any line and then I start, obviously those first two coordinates would be horrible. If I went to the first and the third, that'd be not that bad, but it's still not great. Second, those 2 points, that's nah. These two are not good because all the points will be above that blue line. First and last. You know, the first and last, wouldn't be that bad, but they use the second and the second to the last, and that does look like it might be the best one in this situation. But anyway, this is all about practice, so I recommend using the second and the second to last the way they did, so you could see if you get the same answers that they do. Let me get rid of this line. Now notice that the answers, they don't say your answer has to be, it says sample answer. Because what if you didn't use the second and the second to last? It would be slightly different. But notice that their slope that they ended up with is 3.6. That's more realistic, right? So it's okay to have decimals. You could use decimals, just use a calculator when you input, like right here they want you to input 3. So you go 3.6 times 3 plus 8.8, and you'd be able to get your output for the given input, 3.3. Anyway, I hope this little video helps.